Hey everyone! Today we are going to further explore the topic of radical expressions. Let's get started. Now before we do our first example, let's read our notes. To divide a radical binomial by a radical monomial, we want to multiply the numerator and the denominator by the denominator's radical. Be sure to distribute the radical to the numerator when necessary. Now, the reason we multiply the numerator and the denominator by the denominator's radical is to rationalize the denominator, since we always want to have a rational number in the denominator of a simplified expression. So, if we multiply the numerator and the denominator by the square root of 3, in this case, we want to make sure that we distribute the square root of 3. And since it's underneath the radical, we only multiply the two factors that are underneath the radicals together. So, the product of 48 times 3 can be found by 3 times 48. Then, we'll put the factors of 75 and 3 underneath the same radical. And we'll express them like this to show our work step by step. Now, the reason we multiplied the denominator by the square root of 3 is because we know that the square root of 3 times the square root of 3 is 3. And that was our act of getting rid of the radical in the denominator. Now, let's multiply 48 and 3. Now we know, without having to reach for our calculator, that 8 times 3 is 24. Carry the 2. 3 times 4 is 12, and add the 2. We get 144. Plus 75 times 3. Again, we can find that without having to reach for our calculator. 3 times 5 is 15. Carry the 1. 3 times 7 is 21. Add the 1 for 22. And in the denominator, 5 times 3 is 15. Now, we got lucky in this example because we have a perfect square underneath the radical in the first example, and we have a perfect square under the radical in the second term. The square root of 144 we know is 12. And we know that the square root of 225 is 15. So we'll simplify and combine. 5 times 12 is 60. And 60 plus 15 is 75. And since 75 is evenly divisible by 15, our answer is 5. Now let's consider the second example. But before we do, let's read our notes for the definition of a conjugate. Let's read. Conjugates, numbers of the form a root b plus c root d and a root b minus c root d, where a, b, c, and d are rational numbers, are called conjugates. The product of conjugates is always a rational number. So let's take their word for it and see what happens here. Notice in this example, we have a binomial denominator. This is different than our prior example, because we can't simply multiply the top and the bottom by the square root of 5 to eliminate this radical, because if we did, we'd end up with 3 root 5. We wouldn't be getting anywhere as far as getting a rational number in the denominator. So, let's use this trick such that the product of the conjugates is always a rational number. So let's clearly identify the conjugate of the denominator. Since it's of the form binomial and an opposite, we'll copy that here. So since the binomial in the denominator is 3 plus root 5, its conjugate will be 3 minus root 5. So let's multiply the numerator and the denominator by 3 minus root 5. But wrap parentheses around it so that we remember to distribute or FOIL. In this case, since the numerator happens to be a binomial as well, we're going to FOIL both the numerator and the denominator. So let's do our work in the next step. 2 times 3 for our front product, we end up with 6. The outer product of 2 times negative root 5 is negative 2 root 5. The inner product of negative root 5 times the 3, we end up with negative 3 root 5. And the last product, we have negative root 5 times negative root 5. Since a negative times a negative is positive, and root 5 times root 5 is 5, we get plus 5 for our last product. Let's follow our steps again in the denominator for FOILing process. A 3 times a 3 is 9. The outer product of 3 and negative root 5, we get negative 3 root 5. And the inner product, we get positive 3 times positive root 5 for plus 3 root 5. And the last product, positive root 5, negative root 5 for negative 5, since the square root of 5 times the square root of 5 is 5. Now let's combine like terms in the numerator. Here we have 6 plus 5 for 11 for the 2 integer components. And for the 2 radical components, we have negative 2 root 5 and negative 3 root 5 for a grand total of negative 5 root 5. In the denominator, we combine the 2 integer components, a 9 and a negative 5, for 4. And also notice that our 2 radical terms cancel since they're opposites. So we've now illustrated an example where we can rationalize the denominator by multiplying the numerator and the denominator by the conjugate. Let's try this concept of rationalizing the denominator by multiplying the numerator and the denominator by the conjugate. We'll do this to reinforce our concepts. So let's clearly identify the conjugate of the denominator. Since the denominator is 2 minus the square root of 2, its conjugate will be 2 plus the square root of 2. So let's multiply the numerator and the denominator by 2 plus the square root of 2. And again, let's make sure we show all of our work just to be careful. Now, let's FOIL the numerator. I have 4 times 2 for 8. The outer product, I have 4 times the square root of 2. The inner product, I have 2 times the square root of 2. And the last product, the square root of 2 times positive square root of 2 is positive 2. In the denominator, FOILing our result, we get 2 times 2 for 4. The outer product, we have 2 times root 2 for positive 2 root 2. The inner product, we've got negative root 2 and integer 2 for negative 2 root 2. And finally, negative root 2 times positive root 2. Here we end up with a negative product. However, root 2 times root 2 is 2. Now, let's simplify by combining like terms in the numerator and the denominator. Combining the 8 with the 2, we get a 10. And combining our two radical terms, we have 4 root 2 plus 2 root 2 for a grand total of 6 root 2. And in the denominator, let's combine our two integer components. We've got 4 minus 2 for a grand total of 2. And just as we saw in our previous example, the two radical terms in the denominator cancel. That's our act of simplifying our expression by rationalizing the denominator. But let's watch out for this. In our numerator, we have two terms that have a common factor. Always think of your common factors to further simplify your example. Here, since 10 and 6 have a common factor of a 2, I'm going to undistribute, and I end up with 5 plus 3 root 2 all over 2. Since we have a common factor in the numerator that cancels with the denominator, we may now actually cancel the denominator altogether. So our final simplified answer for this example is 5 plus 3 root 2. And that's our answer. And this completes our segment of radical expressions.
Made with Doodlecast Pro.